chapter 15. It's going to be section 6, 15.6. Triple integrals.
I know we didn't cover 15.5.
Yes.
Are we going to or no?
Oh, did I miss something? What's the topic 15.5?
It is the surface area.
Yes, we are not going to copy a. We are not going to do surface area.
Okay, because I just noticed that it was on WebAssign this morning for the assignment. So.
Oh, I should have taken care of that. It's not in mine.
Okay, I noticed that.
Oh, wait a minute. I take that back. It is. Now, I want to do triple integrals first anyway, because that's what I've set myself up for. That will have no effect on surface integrals, so I guess I can. Let me think about that. So sometimes I do surface integrals and sometimes I don't, which is what the confusion is in my brain. It's a small application of, well, you can imagine what it is. Imagine the surface in 3D space. It's finding the area of that surface, and it's really just an ugly function where you plug and chug. Let me just hold off on that one. If we have enough time at the end of 15 when we've done everything else, I'll go back and look at that, and
okay,
I might just add it on as an application, because that's it. It's basically an application of double integrals, and my mindset was on triple integrals already. So let's get these guys moving. Right. The nice thing about it is that it's really an extension in many ways to what you do in double integrals. Notation is very similar. What you can and can't do is also very similar. So I'm going to give you the simplest example of a triple integral would be written like this. And 0, 1, 2, 4, 3, 6. X squared y z to the 4 dy dx dz. Now, in a much more general way, that would be the generic way of writing all triple integrals. You're doing a triple integral over a three-dimensional region R, and the function is going to be a function of x, y, and z. So typically, that could be written in two ways. You could say fxyz is equal to, as I did here, x squared yz to the 4, or you could call it w equals x squared yz to the 4. So do you see, in a way, this is really fourth dimensional. It's a three-dimensional triple integral, but there are four variables. So it's essentially 4 dimensions. So you might think, what would that look like? Well, can you imagine the region R? In this case, it's a cube, a cuboid floating in 3D space. And at every single point in that cuboid, it has a temperature. And the temperature is given by, say, this formula. Then when you do the triple integral of the temperature density function, I guess I would call it, what you're finding is the total amount of heat energy, temperature, I'm assuming is heat energy, in that block. So it's like adding up something, right? It's a total. And this is the thing that you're adding up. And this is the region in 3D space that you're adding it to. So technically, it's a fourth dimensional thing, because for every point in 3D, there is a fourth variable, w, which uses the x, y, and z coordinates. Now, once you've done triple integrals, I'm not sure you pronounce them this way, but couldn't you do quadruple integrals and pentagonal ones? And oh, do dodecahedron integrals. Does anybody know what a dodecahedron is?
Isn't it a 12-sided figure?
Right, so it'd be a 12th dimensional variable, right? So you could imagine that there's no limit, really. Once you figure out how to do double, can't you just, what we're going to do, in fact, can't you just extend it to 3? Now, in this particular combination, y is first, x is second, and z is third. So that would mean that z would go from 0 to 1, that x would go from 2 to 4, and that y would go 3 to 6. Now, if no one had ever told you, and I just stuck that down and says, go for it, guys, what do you think the process would be? I don't need the details, but what would the process be?
Work your way out.
So you do that guy with respect to y?
That's my hunch.
You're right. It is the right hunch. Then do that guy with respect to x, and then do that guy with numbers. When you do a triple integral, doesn't the end one have to be numbers, just like in double integrals? The final left-hand side one, right? Are you allowed to switch these around? Well, in this case, yes. If I just switch my, like shuffling cards, couldn't I have done the x first, the y second, and the z third in this particular question, at least? Is this particular question variable separable? Some will be, but is this one variable separable?
Yes, it is, right?
Yes. And if I was, I would do z goes 0 to 1 and do a z to the 4. And I do x equals 2 to 4. And I do an x squared. And then I do a y equals 3 to 6. And a y dy. Would you agree that this would probably involve a lot less work than essentially doing that with respect to y, then getting that answer, then doing it with respect to x, getting an answer, and then finally doing with z? So moral of that story is, if it is variable separable, then it's probably a good idea to separate them. And since this one will be 1/5 z to the 5, evaluated at 0 and at 1. 1/3 x cubed, evaluated at 2 and at 4. And 1/2 y squared, evaluated at 3 and at 6. Okay, that's going to be a 1/5. Yeah, that 440, what's that going to be? 444, 64. Take away 8, 56 thirds. And that's going to be 36, 18. 18, take away 9 over 2, 36, take away 9, 25 over 2. And that'll cancel with that, and you get 5, and that'll cancel with that, and you get 28. Oh, if I got that right, I'm doing the lottery today, but you got the gist of it, right? I'm just curious, is it right? If someone has the time and inclination, they could check that for me. So at least where we are right now, triple integrals are not really a big jump in concept, are they? If I gave you a triple integral like this, would you feel comfortable you could do it? So let's.
I get a 140 thirds. Putting it into a calculator.
I trust calculators, not me brain. Doesn't mean my process is wrong, just means I can't count in my head, which you already know. Okay, well, let's look at a different version.
Professor,
Yes.
if two of the variables aren't separable, but one of them is, can you separate out that one by itself?
I think you'd have to phrase that a different way. Two of them are separable and one isn't.
Okay, yeah, that way too, I guess.
The interdependence of the third one will probably kill it. So the short answer is probably not. Wait till you've done the integral of the one that you can't separate, and then you'll be left with a double integral. And if that double integral is separable, then you should do it. So let's see if this one, here's that guy there, right? I'll make one up, 2e3. Let's have this one from 0 to x plus y. And it's going to be 2xy. It's going to be a dz, a dx, and a dy. Now, if you notice that in this integral, one of the limits of integration contains a variable. Right. Now, that one there kind of stops me doing a three-way variable separable, right? Because this has x plus y's in it. That stops it. So we're going to do that guy first. And it depends on what this guy ends up looking like, whether or not the bit that's left is variable separable. So it's no guarantee that just because these are numbers, it's going to work. Because couldn't you have two sets of numbers, but have x plus y here? And that wouldn't be separable either. Now, I like, as you already know, to add in who the limits of integration belong to. And because that's a dz, does it not make the first one z's? Because this one is x, doesn't it make the middle one x's? Because the last variable is y, it makes the outside one y. So we should be comfortable about how to identify which limit belongs to which variable. So this fella here is going to be integrated with respect to z. Well, if I'm going to do that, I just need to figure out what the antiderivative of 2xy is with respect to z. What is the antiderivative of 2xy with respect to z?
2xy z.
Thank you for saying z. So we are now looking at y equals 0 to 1. And from an x equals 2 to 3. Now, if you plug in x add y, you get 2xy, x add y, take away nothing. So that's basically what you get. So do you see that what we're now left with is this double integral? Right, so we've taken care of the z's and now we have a double. So triple integrals turn into double integrals, right? Now, is this one variable separable?
After you to distribute the 2xy, yes. Never mind, I take that back. It would not be.
Agreed. Now, in a different world, can you imagine this integral was 2x squared y cubed dx dy, right? Imagine that's what I'd got, because that could happen in a different world, right? Would that one be variable separable?
Yes.
So do you see that the answer to your question is a little bit less obvious? You may end up, even if one of them is not separable, right? Because the limits of integration have a variable in it. You may end up, after you've taken care of that one, with a double integral that is or is not variable separable. If it is, I would separate them. If it's not, you don't have a choice, right? You've got to do what you got to do. So for this particular situation, I think it would make sense to distribute the 2xy to make integrating this a little bit more obvious, right? I think if I left it as this product, I think when you do the integration with respect to x, you're really making your life harder than it should be. So we're now going to do this guy. So it's going to be the integral from y equals 0 to y equals 1, and let's see what we get. With respect to x, we get 2/3 x cubed y, plus, with respect to
Couldn't
x,
you also pull out the 2 to begin with all the way out to make it a little
this
bit
2?
easier?
Sure.
Yeah.
Yeah, if I'd thought about it, I would have done it, but you're right. Any constant that's in the way, actually, even fractions are good. So, you know, if it was a half xy, I would have, you know, pulled that up. Now, this is going to be evaluated at 2 and at 3, and then dy. Okay, let's see what we get. It's integral from 0 to 1. If you plug in 3, 3 cancels 1, 9, 18y. If you plug in 3, 9y squared. It's not too bad. If you plug in 2, 4, 8, 16/3 y. If you plug in 2, 4y squared, you get that. If we just keep going for a little bit, 18y, take away that, well, that's 3, that's 54. I'll try and make a calculator this time. I have 54/3, take away 16/3, leaves me with 38/3 y, and 9 take away 4 gets me plus 5y squared dy. This particular one becomes, well, power rule 1, 19/3, 5/3 y cubed, evaluated at 0 and at 1. And what does that get me? That fella plus that guy, take away a whole load of zeros. That guy gets me, oh, would you believe it? Final answer's 8. That could have been a lot uglier. Now, as always, I've got time constraints. I took this entire question from start to finish. In the future, I might well get to a point where, hey guys, look, we've now got a double integral. We all know how to do double integrals, ... right? You fill in this, you know, you finish it off yourself, right? So if we take a triple integral and we do some work on it, it'll become a double integral, right? And I would hope, unless it's a really weird looking double integral, that you should be comfortable about finishing that off. That seems a reasonable assumption. Now, of course, if I do that in a situation that you don't feel comfortable, you should tell me, hey, can we do that anyway? I'd like to see what it looks like, and I will do it. Any questions so far? Triple integrals, 3 variables, dx, dy, dz, any order you like, provided the limits of integration follow. Make sure that you always finish with numbers. If you can, it's variable separable. Probably won't be, but if you could do it. Once you've done one of the variables, the first one, you'll be left with a double integral. That may or may not be separable. And if it is, then you should do it. We good? Any questions before I move on? Oh, good is good. I like good. So this one is like question 3. The integral from 0 to pi, the integral from 0 to 2, and the integral from 0 to the square root of 4 minus z squared. Z sine x dy dz dx. And for my benefit, x's go there, z goes there, and the y's go there. Well, because of this one, I must do that. I won't even think about variable separable until I've done this, right? And then I'll have a double integral, and I'll look at what's in front of me and make my decisions after that. So I'm going to have from 0 to pi on the x's, and from 0 to 2 on them. If you integrate this fella with respect to y, you will get y z sine x evaluated from 0 to a really ugly looking 4 minus z squared. I am not happy about that guy. Are we okay about z sine z integrated with respect to y just gets you zy sine x? I mean, I could have stuck the y after the sine if it looked better to you. Now you plug in this guy for z, you get a square root with a z. I'm just going to change the order because it looks prettier in my brain. And if you plug in 0, you don't get anything. So you're now looking at this guy. So we have done one of the triple integrals, and now we are down to a double integral. So far, so good. Okay, let's look at what we've got. Numbers, numbers, that's a good sign, right? Is this one going to be variable separable?
Yes.
It is, isn't it? You agree? So I would split it as a 0 pi of sine x dx and of a 0 to z square root of 4 minus z squared dz. Now I'm going to stop and do my dot, dot, dot thing. Would you agree that one is just a negative cosine evaluated at 0 and pi? That one's not as nice. What technique will I use to integrate this? Because this is really a Calc 2 question.
That's a U substitution.
And 4 minus z squared is a U sub, agreed?
Yeah.
Right, so can you pretend that we just spent the next 5 minutes doing that, and this is not the right answer, right? No way is it the right answer, but it's a half times 42, in which case the answer would be 21. So you'd get the two answers right separately, and then you'd multiply them. Are we good with the process? Triple integral
Yes.
becomes double. Depends on what you get. Sometimes you can't separate, in which case you just do them in the order they're written. If you're lucky, I think if you're lucky, they're separable. And that turns into two separate integrals, but they're both Calc 2 questions, which is really just an extension of the skills that you've got. Haven't you done an awful lot of Calc 2 integrals in double integrals? Right, you've integrated a lot of single variables from 0 to pi, 0 to 1, right? So it's a thing that you're probably quite comfortable with. Okay, then, oh, darn it. No, it's not a darn it, but it is something I'm glad I remembered. Hold with me thought process. I've got something to show you. There we go. Okay. I would like to talk about non-math things for a second. And here we go. See if I can make this bigger. There you go. Oh, maybe too big. A lot of you, unless you're exceptionally independently wealthy, will be looking for scholarships. And the OC Foundation, which are, I'm sure you've heard of them, there's some really nice people who donate money to the college so that we can give students scholarships. And that organization is called the Foundation. And we have $300,000 in scholarships to give you, right? Free money, right? Big chunk of change, $300,000. So I'm trying to advertise this. I don't get any cut. I wish I did. Couple of true stories for you. I've had, over the years, I've had students who've said things like, oh, there's no point in me applying for it. I have a job, they're going to give it to someone who doesn't have any money. That's not always true. Do you know a lot of scholarships are based on what you're going to become, not how much money you have, and none of you are millionaires. So apply. And they applied and they got it. And the reason they applied is that so many of you have that exact same mindset. Why should I bother? I'm not going to get it. Well, if everybody did that and one person did, and it was you, Anna, you'd get it. Do you see the logic of this? You can't win it if you're not in it, right? So apply for it. That's the number of students I've had who've said, they're almost amazed. I got one, they say. And I'm not that amazed because you deserve it. So this is the general information about it. This is the one they sent me. Did they send you a similar one in your OC email?
Not
I'll
sure,
have to look
but
at
I'll
it.
be checking it out.
Okay, check it out. See tomorrow if you say, nope, I haven't got it, then I'll just copy this email and I'll send it to you so that it's got it. It basically gives you a link to register. And what the cool thing is that you can register, all your basic information and what your goals are and so on and so forth. And then they can go looking for scholarships that suit you. And there's all sorts of scholarships. There's a lot of scholarships for people who want to become engineers. Mostly because people who have been engineers and have made lots of money very often give scholarships for engineers, right? So a lot of you are in that mind, go look for it. But if you do get a scholarship, I do get 10% off the top, okay? No, I don't, so please don't send me. I would like to keep my job. Okay. And a little distraction from what we've been doing, but that's fine. Okay. So look into it. You probably can go to Canvas. You never know what kind of things get dropped into Canvas as well. And you might be able to find it there as well. So let's return to what we were doing, which is triple integrals.
I do have a question. Looking
Yes.
at the homework assignment on my number 2 for 15.6, there's a triple integral. You're taking it with respect to y first, but ln of x is the high number. So
Okay.
it goes from 0 to ln of x.
Okay, let's just do that. Okay. So the one I've got may not be exactly yours, but it'll be in the same gist. So I'll get 5 to 7, 0 to 2z, that's important as well, and 0 to log x. And the function is this fella, and the order is y, then x, and then finally z. Now this one's actually a very good question. Do you notice that the z, the last integral, is always going to be numbers? If I saw an x or a y here, I would immediately say that question's stupid, it doesn't make sense. Why has WebAssign done that? It doesn't. Now x is the middle one, and the first one is y. So is it that log x that's throwing you? We're going to do it in a minute.
Yes, that's what's throwing me.
Okay, let's have a look at it. So we have a z equals 5 to z equals 7. Nothing I need to worry about there. I'm just repeating myself. And I like that. Now, here it goes. If you integrate x e to the negative y with respect to y, what do you get? X e to the negative y with respect to y.
Negative x e to the negative xy.
No, so close. Just that.
Ah,
Think of what you would have done if it had been that.
I did not mean to say xy up there.
Okay, so you wouldn't have written it down. Then that's the right answer. Yeah. Anyway, I thought I was the only one who was allowed to use did you all catch that deliberate mistake? Y equals 0 to y equals natural log of x. Right, let's take this, see what that turns into. I do not know why textbooks don't put limits on things, especially when things start getting a bit wonky. To me, isn't it helpful to know that this is to do with x's, but this is to do with y's, and actually physically writing it down just kind of makes my brain work better. Right, if you replace the y with log x, what do you get? You get negative x e to the power of negative log x, which is definitely scary. And if you plug in 0 for it, so that's the first one, you get negative x e to the negative 0, which is just 0, dx dz. It's not as bad as it looks because it superficially looks really ugly. Okay, let's take care of this guy. E to the 0 is 1, so won't that be negative x? But a negative of that negative, you're going to get a plus x there. All right, let's take this over here. I want to find a nicer version of e to the negative log x. How about e to the natural log of x to the power of x minus 1? And why am I going that route? I'll show you a different route that gets you the same answer. Well, what does e raised to the power of a natural log typically get you?
The argument of the natural log.
Just the same number?
Right, so you get this, right? So e to the natural log of this is just that. Now, there was an x there, still there, still there. Doesn't x times x to the negative 1 get you 1? Slightly different approach, same question.
I think that will be a negative 1 because it was a negative x to start, but not a big change.
Oh, right. There we go. Now, in this case, a slightly different approach is to write it like that. And then to notice that e to the power of natural log of x is x, and there's that negative 1. So it's just the algebra of making something look pretty. Do you see why style points can sometimes be helpful, not just being fussy? Yeah, making things look nicer can help you.
Yes, yes.
So we have a negative 1 plus x. Now, in this question, x is going from 0 to 2z, and z is going from 5 to 7. In this case, there's no variable separable, really. And why is that? Because you can only do variable separable if both sets of integration limits or numbers, but this has 2z in it, so it was never going to happen. So I do this fella, and with respect to x, you get this fella evaluated at x equals 0 to x equals 2z. Well, what's that going to be? It's going to be an integral from 5 to 7 of negative 2z plus a half of 2z squared. Oh, take away a whole load of nothings. Right, I'll just dot that. Would you agree that if you foil this out a little bit, it's just basically a power rule in z's evaluated at 5 and 7, and you'd be finished.
Yes, that helps a lot. Thank you.
Right, now, on that same question, but with one change. Suppose it wasn't y equals 0 to log x, but y equals 0 to y equals x. And all the other stuff is going on. When you integrate this fella with respect to y, you'll get negative x e to the negative y. That won't change. You'll have a y equals 0 to y equals x. That will get you negative x e to the negative x. And you plug in the 0 guy, you eventually get plug it. You got a plus x. That fella there is going to get integrated with respect to x. That's a half x squared. What technique would I use to integrate this guy?
That's an integration by parts.
Correct. So do you see that you could have a U sub, you could have an integration by parts, or you could just get lucky and with a bit of algebra, it turns into something that you can just integrate in the usual way without any special techniques. There is a lot of variation in what can happen in a triple integral, right? There's no, oh, this is what you always get kind of thing. You get what you get, right? It depends on what they stick inside the limits into integration. They can make it so that it becomes really nice, or they can make it so that it's a stinker. Right. Next question. I'm just going to see if I can show you it here. There we go. Oh, shooting space. Just need to make it a little bit bigger. There we go. That should help. Okay, here are some examples of the homework questions. We've covered ones very similar to it, but this is a new guy in time. Question 4. I don't know why they pick letters. They seem to almost like pick them at random. Looks like they like E. Can't think of what that stands for. Anyway, evaluate this triple integral. The function is just y dv. The region E is given using essentially set builder notation. So we need to translate all of this information into limits of integration. So as I look at this, although you can't see it yet, I am writing it down. I'll write down my triple integrals and I'll write y. And now I'm looking at the 3 guys in town. X goes from 0 to 8. Y goes from 0 to X. And Z goes from here to here. I have to make a decision about the order in which I set up my triple integral. Okay, so I'm going to work from the outside in, right? So the one that's right at the end. Which variable, X, Y, or Z, would make most sense in this situation?
X.
I agree. And though you can't see, I'm writing that down. Why did you choose X? What was your clue?
It's the only one that has numbers for its limit.
Agreed. Okay, now we can forget about the X's. I have a Y from 0 to X, and I have a Z from X minus Y to X plus Y. Which one goes in the middle? The Y's or the X's?
I would put the Y because it's 0 to X, and it would trim it down. If you had the Z, you would still essentially have a big mess to use the 0 to 8.
Okay, that is exactly the right thing to do. And obviously there's one left, so that is Z, and it goes from a lower limit of X minus Y into an upper limit of X add Y. Right, I'll show you this guy now. Oops, I just wrote dx twice there. Right. And I'll try and show you some clues to how to take information that was written in that set builder notation and use it to decide in the order. And the simplest order is numbers always go at the end. One variable goes in the middle. Two variables goes there. Now, when I mean one variable, do you see how that's got a variable in it, but there's only one of them, it's an X. And two variables, do you see how that has an X plus Y in it? And the reason why you should do it in this order is, when I do with respect to Z, won't I then just end up with functions with X and Y in it? If I then do the Y's, won't I just end up with functions with X in it? And I need to make sure that I do it in such a way that when I've done the first two, I've only got X's left at the end. Here's another one. I'll keep that one there. I don't have time for it. Tomorrow we'll probably do something less, but let's just focus on the order thing. To keep them happy, I'm going to call it E, but I would call it R myself. Okay. And let's pretend the function is Y again. Okay, Y goes 0 to 1, X goes 0 to 2, Z goes 0 to XY. Okay. Who goes here? X, Y, or Z, limits of integration?
Z.
Okay. Forget about them, right? Done. In this question, who goes next? X or Y, or does it matter?
It would be X because we're integrating a value of Y.
It doesn't really matter, does it?
It doesn't really matter, does it?
It doesn't really matter, does it?
Well, that we're in a disagreement. It either does matter or it doesn't matter. And the answer is, in this particular case, it doesn't matter. Right. So if you plug it in, you could do the Y equals 0 to Y equals 1, or the X equals 0 to X equals 2, right? And because both limits of integration are numbers, it essentially doesn't matter. Now, it might matter for calculation purposes, that it's easier to do the x's before the y's. But you won't really know that until after you've done this, right? And once you've done this first integral, look at what your double integral is like. And if you don't like the x's before the y's, you might choose y's before the x's. There might be good, computational reasons, that's all, right? Mathematically, either one is good. Now, if I'd said to you that this guy was x, so x goes from 0 to 2 and y goes from 0 to x, do you see it now does matter the order? And wouldn't the y have to go in the middle? That
Correct.
makes sense. So first, one variable, two variable, will get you out of a whole load of trouble, right? When you're trying to find the order of integration. I think WebAssign, for the most part, is quite nice. When they write them down in this format, it seems to me, at least for the few I've scanned, that they give you them in this goes, then this goes, then this goes. They kind of write it in order that they're going to be from left to right. So that kind of makes your life a little bit easier. But there's no reason in the world where they couldn't just feel like, writing them down in any old order they like, in which case you would have to have that decision. And then later on, you're going to be given the region of the triple integral where you're going to integrate it in terms of from z equals x to z equals x plus y, and from y equals 0 to y equals x squared, right? You're going to get it written down in terms of algebra, not in terms of interval notation. And in those situations, you really do need to figure out very carefully the order of integration. If you ever do a triple integral and there's a letter left over, you've done it wrong. Agreed? So if you think the answer is 42x, something's not right. Just ain't going to happen. Okay, we all say hi. I'm going to hang